Hello everyone, welcome back to the chapter 3, and then today we're gonna keep doing the some examples, and hopefully you guys understand how we're gonna do with the parabola, how to graphing, how to sketching. Um, so another thing is I want you guys to remember, we can use the table by any time, but now we can move on a little bit advantage. So which is we can using the graph with transformation. So first thing first, if you remember how to graphing with y equal to x squared, so I strongly recommend you guys can start with the y equal to x squared first. Well, luckily we got a straight line, so 0. So what we do is we could just write down the y equal to x. Well, that doesn't look like it. Um, there you go. So y equal to x squared. So if you want graphing the y equal to x squared minus 3, so what we do is remember the transformation, which is the translate by 3 units in the negative direction of y-axis. So which is we're going down by -1, -2, and -3. So this is your turning points from 0, 0 to 0, -3. So which is your graph of it looks like exactly the area looks like the symmetry with between the x and y axis, and then it just moved down by 3 units, and turning points become to 0 to -3. Hopefully that makes sense. And normally we're asking the y intercept, so which is when x equal to 0, so y equal to x squared minus 3 when x equal to 0, which is y equal to minus 3, so which is 0, -3 is your y-intercept. So, and x-intercept, which is when y equal to 0, so which is 0 equal to x squared minus 3. So both sides plus 3, which is 3 equal to x squared, and x equal to the positive and negative square root of 3. Hopefully that makes sense because you are square root on the both sides. Because we remember the negative root 3 square is still equal to 3 as well. So which means we have 2 x-intercept, which is -3, 0, and root 3, 0. So which is negative root 3 and root 3. That's the coordinates you remember. So move on to the next, which is the little bit of reflections. So what we do is we can use it as a reflection with using the transformation part. The first thing first, uh, let's do a quick uh, movement first. So what we do is we write down the y equal to x square. So what we do is we're using the transformation. So first thing first, we graphing. So we're graphing with the y equal to x squared. That looks like y equal to x squared. Make sure it's touching on the 0, 0. So, excuse me. And then now what we do is we do a little bit part. So we do side by side. So what we do is we do y equal to negative x squared now. So negative x squared, which is a reflection by x-axis, so which is exactly looks like the y equal to x just reflected, so negative x squared. And now it's some plus 1. Remember, if you plus, you're moving to the left. If you minus, you're moving to the right. So x plus 1, so which is the final answer, which is you're moving to the 1, -1, 0 here. So your turning point is moving to the left by 1 unit, which is a 0, 0 to -1, 0. And then you can say your graph will be looks like this. y equal to negative x plus 1 square. Hopefully that makes sense. But now they're asking your x-intercept. So when x-intercept, which is y equal to 0, which is when 0 equal to minus x plus 1 square. So when they can equal to 0, which is x plus y equal to 0, so which is x equal to negative 1. Hopefully that makes sense. And now we're using y-intercept, so y-intercept, which is x equal to 0, so y equal to negative 1 square, so which is negative 1, so which is 0, negative 1 is your y-intercept. Hopefully that makes sense. And the last transformation, which is turning point form, remember turning point form. So we have turning point form, and now we're gonna sketch in the graph. So turning point. First thing first, you guys have to remember. The graph will be like. We can rewrite this a little bit trickier, so we can restart with when y equal to x squared. So 2x squared first, maybe 2x squared. So when y equal to 2x squared, so will be like that. Y, so which is 2x squared, so will be narrower to y equal to 2x squared. So now we have that. So with transformations with translation by one positive direction of x-axis first. So what did that mean is your turning point we start with 0 0, right? So you transformate to excuse me, so we transformate to this one to the right hand directions, which is one directions, which is 1 0, so which is like that, which is like that. So not the straight line. What's going on? So like that. There you go. So now it's y equal to 2x minus 1 squared. And what we do now is we're gonna a little bit move out. So plus 3. So plus 3 is like the whole graph are shaping by 3 positive direction to the y-axis. So which is you're moving up by 3 units. So your final answer will be from 1 0 to 1 3. So for example, that's 1 3. So it'll be like that. So that's your final answer, y equal to 2x minus 1 squared plus 3. So your turning point will be 1, 3. TP will be 1, 3. And we need to find out your y-intercept, so which is when... So you clearly can see not crossing the x-axis, which is we don't have any x-intercept. So now what we do is y equal to something when intercept when x equal to 0. So which is, let me think. So which is y equal to 2 plus 3, which is equal to 5. So we can say is 0, 5 is your y-intercept. So now that will be 0, 5 to crossing the y-axis. So hopefully that makes sense. This is how you're graphing the turning point form. Later on, we're going to show you how to graphing this polynomial form. So that will be a little bit challenging, but you'll feel like this is going to be a similar. See you guys next time, and then hopefully make sure you guys can practice with the goals and then see how we go. See you guys next time.